Hello, everyone, and welcome again. So yesterday, or the previous lecture, we went over the first portion of the written materials. Today, we're going to be looking at the topics in the second portion. We're also going to be doing a little bit of an experiment where we compare and contrast the collisions and stuff for Unity versus Unreal. So the second portion starts off with the HUD and projectile damage and stuff. Let's take a look at how the widgets and stuff can be created in Unreal. So the way we're doing it, we've set up a widget HUD, and we've done some things so that we've set up some containers to organize our things a little bit. Let's actually take a look at starting from a scratch blueprint. So under user interface is where your widget blueprints are, and of course they're behind this bar. There we go. So we'll just name it example widget. And this is the widget editor for Unreal. So in here we have a screen represented on here where we can lay out the different user interface elements that we want to show, like on our HUD or any other menu or anything like that. A couple of things I want to point out while you are in here. You'll notice the DPI scale is set to 0.67. That's because it automatically detects that we're currently on a 1920 by 1080 screen, or a full HD. So it scales it down so we do have the ability to see our details and stuff by normal. If we actually look at the numbers over here, up at the top ruler, as well as the side ruler over here, the screen size and where it locates, where its positions are set by default for a full screen of 1920 by 1080. So even though it says 1280 by 720, don't worry about that. That's just its preview resolution so that you can see everything as well as have the toolbars on the side. Next up, we can drag things in from our palette to actually show on the screen. For our example that we're using, the first thing we create is a ammo bar. So we drag in a text, we can drag in a progress bar and stuff, and we could position them like this and position them all correctly on the screen like that. But there's a few other tools and container tools that are quite useful that we use to lay out different things in our widget. Since we want our text block on the left and our progress bar on our right, we can actually search for something called a horizontal box. If we actually put this directly on our canvas panel, we can position that and size it as we like. And we can scale it up like that and move it around and stuff like that. And this allows us a very quick, easy layout tool to actually drop our other elements onto it. And totally didn't drop it on there. There we go. And we see that now that they're added as a child of that, they're going to organize themselves from left to right in this horizontal box. We can adjust some other things once we have them inside that box. We can say, well, let's have this fill, progress bar, we can set to fill as well. And we can adjust how big we want, like what ratio do we want of the text versus the actual progress bar. So we could say we want our progress bar to be twice as large as our text, and we can see it fill it up in here. Our text block, we do want horizontally centered, so it's nice, easy to read inside this box. So that's just one of the reasons why we're using these horizontal boxes and vertical boxes to really just organize everything a little bit cleaner. So, and our text block will add a little bit of padding. Let's add 3 padding, just to give it some space before the progress bars in there. We'll also add 3 padding to that, so they're not overlapping each other like they were. All right. So if you've got that all set up, we can then select the individual items and change all their details and stuff, this item up here in the top is actually what it will be called in code or the script when we want to reference it. We'd probably want to rename it from text block 76 to something a little bit more representative of what it should be. So for this, we just have our ammo. So we'll call this ammo. And this is our text block, so ammo text. And we see it does change the name up here that was represented inside the other, inside the, come on, square brackets. There we go. Progress bar, we'll update that since this is our ammo bar. And the entire box itself we can rename to ammo info. All right. We then just have this text block currently saying text block. Well, that's what it comes with by default, and we can actually change that under the content of text. We can just hard code what we want it to be right here. Ammo. And we can even right align that so it's up on this right side of the box. And we can just lay this out kind of how we want. Now the documents do talk about how you can lay it out. It's very important that you have the hierarchy set up correctly and that these ammo bar, ammo text and ammo bar are inside ammo info. And then we end up adding a vertical box to organize it vertically for the ammo info, the name, and our health as well. So talking about these different properties, the ammo bar is going to be a progress bar. Think of it just like a loading bar or, well, progress bar. Down here, we can change what color we want it to be or what color we want the fill to be. But right now, we don't see that changing at all because our bar is completely empty. So our bar's amount is actually represented under progress and this percentage right here. If we wanted to preview it, we could fill that bar up halfway, but we want this to be actually tied to one of our gameplay elements. So what we do instead is use an option called bind. Bind allows you to create a binding and say what value you want, and it'll actually update as that value changes. Well, in here, we need to get a reference to our player or our character, which has our health elements. So we can get owning, oh my gosh, typing all backwards today. And we can get our owning player. This is currently returning a type of player controller. And there's get owning player pawn, which I believe is what we wanted to use. So get owning player returns the player controller. We can get owning player pawn to return the actual pawn object of our character. Now this character won't have any of the health or anything like that because it's not the base character we made. What we can do is try and cast to specifically our base character where we've added the function to get the health and stuff like that. We'll plug that in. And as our base character, just to show an example, if I try and do get health here, we don't have any of that functionality, but our base character does. Get health, and we've created this function called get health ratio on our base character. In case you haven't gotten that far, we'll check out what that function does. We just connect those execs up so that when it tries to get ammo percent, it's going to try and cast our owning player to a base character. When that succeeds, as the base character, it'll return this health ratio, and we can pass that to the return value. This gets get health ratio, just ask our killable to divide current health over our maximum health. And that'll get our health, and this bar, when we're actually playing, will be based off of our player's health, not just the hard-coded value we put in here. So that's just a couple of things I wanted to clear up about how that HUD is actually working, and a couple of widgets and what the bindings do, and etc. Next up is our health, which we actually talked about in the last lecture a bit, along with our death. I want to talk more about these pickups and collisions and how they're working in Unreal, along with what that inheritance is doing for us. So in there, the documents will guide you through creating something called a base pickup. The reason why we're doing this and not just writing a pickup damage first, it's because this base pickup, it doesn't have any visual components. The only thing it has is a collision sphere. And this sphere collision, it won't be seen in game or anything like that. So all this one's doing is processing collision. This gives us the ability to add our pickup damage as well as our max ammo and have different types of visual components. So for example, our pickup max ammo has a mesh for its visual representation, and our pickup damage has a particle system for its visual representation. But both of them are just using that base pickup's sphere collision. So for example, if we wanted to create a new pickup, rather than having to do the collision code that detects whether it's a player actually inside it before we try and run the pickup, we can just create another child of that of the base pickup, and we can rename it anything. We could, let's say, have new ammo pickup. Sorry, I was trying to think of something interesting, but ran out of ideas right at the last minute. New ammo. So this ammo will actually be like a negative ammo pickup. And in our event graph, it inherits everything from our parent pickup. We don't have technically any code running. All it's doing is the same exact as our base pickup. So let's go ahead and add some sort of visual component, because remember, our base pickup just has collision. That won't be seen in game. Let's go ahead and add, let's do a particle system for this one. Oh, not Niagara. So we'll do a normal particle system, and we'll choose, let's go with the blue fire. You should see that in the viewport. All right. That'll be fine for a visual representation. Then we got to define what it's going to do. Only thing we need to do, we don't have to do any checking of tags. We just need to say what happens when we enter this pickup. So we see when we override and the enter pickup function, it'll automatically add a parent call for us. So we don't need to add one ourselves. But just in case we deleted that and we ever wanted it back, you won't be able to find the parent call just by searching. For an actual parent call of an overridden function, you have to right click and add a call to the parent function. That's how we can get that one back. And we do want that here just because that one will actually call our base pickups enter pickup, which is saying destroy the actor. So back into our new pickup, we need to tell it what to do. So we're given the other actor that's currently colliding with us, and we can do cast to our base character, because actor doesn't have any weapon or anything like that on it, but our base character, even though it is an actor, it's a subtype of actor and has more functionality on it. So we have to do that cast to get exposure to the actual base character functions and stuff. We can then search for, there's add to max ammo is the function we've written for the other pickup. But rather than doing this one with a positive value, we'll say this one's going to take ammo away. So let's pass it -3. So when we hit this pickup, we're going to have 3 less ammo to use. Compile that. Then we got to remember to drag one of them into the level. We play, and we see our pickup over here. If we run into this, we'll notice our ammo bar hasn't changed at all. Well, that's because we started the game with 5 out of 5 bullets, and we just hit that pickup ammo, our max pickup, and our new ammo has dropped to 3 out of 3. Now, because we can't see any visual change doesn't mean that change is not happening. If we were to start the game, I'll shoot once, so we have 4 out of 5, or 80% of the bar still filled. When we hit this, we see the bar looks like it got bigger. Well, that's not true, because 3 out of 3 is still less than 4 out of 5. We've lost one. So just because that's representing a percentage does not mean that the bar is not changing. If we wanted more feedback about that, we could make sure that in this function we could add some print strings or something. Like, let's just add a print string of our current max ammo before we run that plus and the set of the new max ammo, as well as an after. We'll just copy these. And move that over here to print after we've done the set and reload to see what our new max ammo is. And we just added that onto our add to max ammo, so we should see it anytime that function gets called. One thing I'm going to do is make sure my output log is here, just in case we miss the message on the screen. If we run into this, we see it was 5 and now it's 2 because we're subtracting 3. So I kept saying 3 out of 3 before, but it's actually 2 bullets that we get to shoot. So 1 and 2, and that's all the ammo we have now. If we hit this one, that's going to add 5, so we have 7. It was 2 when we first did it, and then after the pickup finished, we had 7. 1, 2, 3, 4, 5, 6, 7. And we're out. So it's a nice way of having all of our pickups functionality, that base pickup or shared functionality, on just this one script. If we ever wanted to add another tag for, let's say, our projectiles to even interact with our pickups, we could add those in here, and then enter pickup would be called for each one of the projectiles in just one spot, rather than each pickup having to be updated for a new tag, or if that tag changes name, we don't have to deal with that. Our pickup can just focus on what it needs to focus on. When I've hit this and when I've entered it with something valid, we're going to do our functionality. So it keeps these very nice and clean, and all that base functionality is going to be for each one. So one thing I want to talk about is the collision settings on this. So we've created this collision element, or collision component, the sphere collision. And we ended up going down here to the collision. I believe by default it does overlap all dynamic. And then for each new item that we added, specifically the ammo one, because that comes with a mesh, meshes also have a collision element to them. So what we had to do when we added the mesh, we set what mesh we wanted, along with made sure that its collision was set to none. The reason we changed that, and if I just reset this back to block all dynamic, and if we were to scale this up back to normal, so let's pretend that's the normal size, and I just hit reset, so that actually is the normal. If we try and hit this pickup, we can't because we're blocked by that mesh. I probably can from like a certain angle. No, not even gonna be able to pick that up. So we disable this one's collision because we only care about our sphere collision. Our sphere's the only collision component we want reacting. So we do change that to overlap all, or sorry, no collision. File save, and we're able to walk through it like normal. The collision component in our base pickup is actually by default overlap all. So overlap is the same thing as setting a trigger. If we take a look at this in Unity, and I'm going to open up a Unity project and create a simple character that can move around so we can kind of replicate our pickups setup that we have here. We'll just create a new Unity project, Unreal to Unity. And while that's setting up, what I'm planning on doing here is just getting a simple character that can move around and based off some inputs, and then add some pickup elements similar to what we've just set up in Unreal. All right, so we've got a blank Unity scene. First thing we're going to need is something on the ground because it doesn't add a ground for you. So we'll go ahead and create. And let's just go for terrain on this. I'm going to edit the terrain so it's not 1,000 like the default. We don't need that big of an area. We can do 50-50 since Unity units are in feet, I believe, and Unreal units are in centimeters. So 50 centimeters would only be half a meter in Unreal, but in Unity, it's perfectly fine. We'll also set it to -25 in the X and -25 so that the center of the terrain is right at 0, 0, 0. We then need a character to move around. We'll throw in a capsule since that perfectly defines character shape and stuff. And you want to move that up out of the ground with 1. We need a script to actually control this character and get it moving around. So now we'll just add it to this and we'll rename this from capsule to player. We'll add that component, new script. We'll just call it player. And you guys don't need this navigation tab, so player script. We'll open that up and get our character moving around. While that's opening, there's one other thing I'd like to add to this. And that's actually adding a component. There's something called a character controller. This is pretty similar to the movement or character movement component that we have in Unreal. And we'll just leave all those the default settings for now. But just wanted to make sure that was there so that when we go to use it in our script, we can access it. We'll want to get a reference to that character controller component. I'll just initialize it to null at first, and then we'll grab it inside our start. We'll say cc, which is a variable that we just created, equals our character controller, and we'll get that component of type character controller. And then inside our update, we can do some input checking. We'll check if certain inputs are down. And actually, we don't. We'll just get the axes directly from the input system. We'll create a new vector for our movement. We'll do vector 3 for movement. We'll initialize it to a 0 vector. And then we'll say movement dot x. Now let's go for the forward, which is z in this system. Equals movement plus equals our forward direction, transform.forward times our input direction, input dot, and we'll be asking for an axis. I'm not sure if you guys are familiar, but Unity has several axes set up for you. There's a horizontal and a vertical axis. Vertical is W and S, or the arrow key up and down. So we can ask it for that vertical axis. And that's going to be pretty much the same thing we have for our axis that we set up for W and S called move forward in Unreal. And then we can multiply it by some sort of speed amount. So we'll create a variable for speed, and we'll make it a serialized field so that we can change it in editor if we don't like it. We use a float, move speed. And we'll initialize it to 5 times our move speed. And then we also want to have a horizontal axis, or our same as our move right. We'll add that into our movement vector. And instead of using the forward for this, we'll be using our right vector times the axis value. We'll make sure to multiply in that speed as well. Last thing we need to do, we've created this variable, filled it out with some things based off of input, and we actually need to tell our character controller to move that direction. Well, character controller has a few different options. There's something called move, as well as move simple. So move takes direct actual changes in translation, whereas simple move is a little bit simpler. It just takes a speed and direction based off of the vector 3. So we'll just pass our movement vector in there. Save that. Let Unity compile it. And play. Got to click the viewport to give it input in the game. And using WASDA, I'm able to move my character around. All right. So next up, let's actually add a thing for this to collide with. We'll go ahead and create just a script at first, and this will be our base pickup. Base pickup. Our base pickup, remember in Unreal, is doing just basically nothing except the collision functions. And we'll actually hop over there and check it out. So our event graph nothing for any of that. The only thing it's handling is when it detects a collision event. And then inside there, it's doing a few other things. It does have a function called enter pickup that destroys itself. So we'll do the same thing for this one. We don't need any starter update. We do need a custom function. So we'll do a void return type. Function name was enter pickup. And as far as input parameters go, in Unreal, we do have an input parameter, and it's taking in the other actor. Well, actor is the same thing as game object here, so we'll just pass in a game object. We'll call it other. So we have that function. And then we also need to handle what happens for an on trigger enter. On trigger enter is, once again, just like this event is handling this component begin overlap. It's a little bit different because this one can be specific to the component. That would be more akin to an actor begin overlap, which does get thrown on there for you. Just wanted to point that out, that we are specifically saying it's only focus on this one component, whereas Unity does not have that functionality built into it. So this one is slightly different. But on trigger enter will serve the same purposes. We're passed in that other thing that it's colliding with. And from other, we can get the actual game object that it's colliding with. Once again, in Unreal, it automatically breaks it down into the other component, the other actor or other object, the actual other component, which index of the other object is it hitting, along with did it hit from a sweep, and what the actual hit results and everything were. But in here, we don't have all of that stuff. Now, very first thing that we were doing when it entered is checking if it is valid. This is valid for actor. All it's doing is doing actor has tag. We can do the same thing. We could have left it outside of a function, but I just left it in a function for future extension later. If our pickups want to override them themselves, then our base pickup wouldn't have to change. So let's keep it a little bit simpler here. We'll just be asking if that other game object we can do a compare tag with, and look for a specific tag that we want. We can say if the other player, and I'm saying if, but I didn't write it yet. So if the other object has the player tag, we'll run what's inside this if. And the thing we would want to run back here, we're branching. If that's true, we do enter pickup and pass through that other actor. So we can call enter pickup and pass through the other game object. All right. So let's go ahead and try and create a child of this. Let's create another script, and we'll call this, let's make a pickup for a dog pickup. Pickup dogs. If we open that script up, it comes with nothing. By default, anytime you create a new script, it'll automatically add what its parent class is, and it always assumes mono behavior. Well, I want this one to be a bit different. I want this one to be from our base pickup. So we can change that right there. And now our pickup dog will inherit everything from base pickup. So even though this has nothing in it, it'll be still running all that base pickup code. And our base pickup, I forgot to do one thing, and that's having enter pickup destroy itself rather. Destroy, and we'll destroy the game object that this is attached to. It's just like doing the destroy actor, passing in self from Unreal. Save. So we need an object to place this on. And so that's a bit different where in Unreal, we can create the objects and it comes with the event graph already attached. We have to attach the script just like a normal component in Unity. So we'll pull this up and we'll just put that on the right side of our character. And we got to make sure to attach our dog pickup to it. Pick up dogs. We'll see that pick up dog script completely empty, only thing inheriting all the base pickup behavior. So if we play this and we walk into it, well, we're just running into it, similar to when I had that mesh have all the collision and stuff. Our sphere is not set as a trigger. So we'll go ahead and make sure that's set. And we're walking through it and nothing is happening. So nothing's happening because I also forgot to add a tag to our player. We never tagged it with a player tag. One more time. Now, when we run into it, we see it disappear. So even though our pickup dogs has nothing in it, completely empty other than saying, yeah, let's also start off from base pickup. So let's change this. And let's say I wanted to have our pickup dog, instead of just destroying like a base pickup, I want to have it print to the screen as well. So if we went to override in Unity or C#, we can add the override keyword. Now by default, it doesn't show our enter pickup here. There's one extra step when you're working in C# to actually expose something to be overridden. We have to add what is called a virtual keyword to anything we want to override. We also need to actually add a protection layer on this. So by default, everything inside a class in C# is private. This is the same, if I put nothing, it's the same as having private there. But we want this to be public so that, and not capital P, so that everything else can actually work on it or change things on it. So save that. Back over here, when we do override again, we see enter pickup. We can override that function. Just like Unreal, when we went ahead and let it autofill, it added that base call into it. So base.enter pickup is the same as the parent call enter pickup that we see inside here. So as soon as we overrid this, it came with that parent enter pickup. Back to the code. I said we wanted to do something in addition to this enter pickup. So let's go ahead and add a debug.log playing with puppies. Yay. All right. So we go ahead and check that out. And we'll see play. When we hit this, we get that print. We're playing with puppies and pickup disappeared. So let's say I wanted to completely override it and I didn't want the puppies to go away. Well, we can just get rid of that enter pickup from the base enter pickup and just do the stuff that we want. We just want this one sticking around, so we won't destroy it afterwards. Play it, and we'll see enter, enter, and each time we enter, we're now getting that pickup. Now, if we wanted to add another pickup, let's rename this one so we don't get too confused and leave things something called sphere. We'll call this puppies. And let's go ahead and change this a little bit. Let's add another game object. Let's add a cube. And we'll shove that on the other side of our character. And this one will be kind of like the negative pickup. We'll call this one mosquitoes. Mosquitoes suck. So mosquitoes, we want to make sure it is a trigger. We can go then, every time we're adding a new pickup, we just need to focus on what that pickup is. Pick up mosquitoes. And our pickup mosquitoes, don't need to worry about start or update. We're not doing anything per frame. We want to change to make sure that it is inheriting from our base pickup. We can override our enter pickup. So what happens when you enter the mosquitoes? Well, you get a print saying ouch. Or you could do something even worse and have it destroy the other character. So enter mosquitoes and it'll destroy you. We'll save that. We'll play this and play with puppies, having a good time. Then we go over to the other side and we are not doing anything. So mosquitoes, I forgot to attach the mosquito script. That would help. So puppies again, still working fine. Hit that and our mosquitoes and character will both be destroyed. So that was just a quick example showing the different collision type things that you'd need to set for Unity and showing how you can do inheritance in Unity and how it would compare and some of the functionality behind it, things like that. Are there any questions about that at all? Anything we went over about the inheritance and overriding, parent calls? So it's been completely silent and there is nothing in chat. You guys can hear me okay, right? Yes, okay. I was just gonna say, I've been talking for about 50 minutes straight and hopefully they're listening. Alrighty, cool. Well, that's actually about it for today. Just a reminder, try and manage your time fairly well so that you can wrap up with everything there and then start working on those lab tasks. We will be having a lecture on Monday, kind of giving you some pointers. I would recommend trying out some of the lab tasks first on your own without looking for any of the help. But if you are struggling with some, you can always check out one of the pre-recorded lectures before Monday or wait till Monday, and then we'll talk a little bit about how to get started on those lab tasks. but you can always go ahead and check that out. It's quite useful to give you some starting points, some nodes, node names to look for, and things like that beyond just what the document description does. Alrighty. So if there is no questions, then I guess we'll go ahead and end it here.